Hi everyone, welcome back to Cody's Lab. So a lot of people have wanted me to play with the Mercury copper amalgam again, so I've got a nice big bag of copper powder here, and I've got a few things that I want to experiment with using the amalgam. First, I want to know if I can use it as like a conductive paint to like encase an object which is normally not conductive, such as an egg, and then perhaps see if I can electroplate it once the amalgam's on there and set up. Next, I want to know if I can use it to fuse two wires together. So I've got a couple of strips of copper here, and we'll see if that makes a strong conductive bond. If so, maybe we could use it as a very low temperature solder. Next, I want to know if it can be used as a thermally conductive medium, like a thermal paste. So I've made up a little heat sink here, which is made of aluminum. And I especially want to know if the amalgam will destroy aluminum. Normally aluminum is completely destroyed by mercury, but I hypothesize that it will only do it if it's in the liquid state. If the mercury is bound up in an amalgam, then it shouldn't react with the aluminum at all. I also want to see if it can be used to seal a hole in a piece of copper pipe. So you can see there's a pretty substantial hole in this copper tube here. So I've sealed that off. We're going to plug that using the mercury amalgam, and then I'll pressurize the tube to see if it seals. And finally, I want to know if the material is hard enough that I could use it to stamp brass. So if I make like a little die using the amalgam, can I use it to stamp a brass tag? You know, make my own coin, or save some time when I'm making the little tags for my trees. So, let's get started here. Let's go up to 12 grams of copper, and from some previous experiments I know I need about 20% mercury by weight, so okay, that's a bit on the excess side, but that's alright, I can squeeze some out. Should have used a dropper. Anyway, now the copper and the mercury won't combine just like this, because the copper has a bit of an oxide coating on it. That's what gives it sort of a reddish-orange color. And it's just kind of inevitable with something this fine exposed to air. So I'm going to add a little bit of hydrochloric acid. This will dissolve the oxide off the copper and make the mercury stick more readily. So let me just get this mixed up into an amalgam. Okay, so here's the mercury amalgam after being all mixed up and washed with copious amounts of water to remove as much acid as possible. And that looks pretty good. It is a little bit goopy. I think I'm going to squeeze a little bit of the mercury out. See if the roughened surface of the egg will adhere to the amalgam better. Yeah, no. Well, it doesn't look like it's going to be used as a conductive paint then. Maybe if I had a thicker layer and I just basically smeared it into a thin sheet. But yeah, it's not going to do what I wanted. It's kind of interesting. Kind of goes a more whitish color, just like squeezing wet sand, I guess. Okay, so I guess we'll move on to the MOSFET switch and its heat sink. See if we can lower the exposure on that just a little bit. There we go. All right, let's see. Okay, so I got that little bit of paste on there. Let's squish on the MOSFET switch. I'm actually going to use a clamp to clamp it down nice and tight. Because the next thing is the copper strips here. Let's see if we can solder them together using the mercury amalgam. So it sticks to the copper rather well, as you can see, which makes sense because the amalgam is mostly copper itself. That's pretty good. Now, let's get the other one tinned with it, I guess. And of course the little bit of acid that might be present is definitely going to help in this stage. It'll clean the copper, acting as almost like a flux. Okay, so those two are bound together. So here's that copper tube with the giant hole in it. As you can see, I've cleaned the area around the hole with a piece of sandpaper. Let's jam some of this mercury amalgam on there. See if we can patch that hole. Obviously this would not be suitable for potable water. But I can see maybe doing this with a radiator or something. You know, the mercury amalgam is really no more dangerous than lead. So now to make the die for stamping the brass, I figured the hole in this roll of tape is about the right size. So we can use that as a kind of a mold. So let's stick that on there. That'll give us a nice circle to work from. Okay, now I need to make a design. Alright, let's just do pinion pine. I could probably have made them a little closer together than that, but that'll do for now, I think. Alright, so I'm just going to stick the mercury amalgam down into the lettering so as to not have air bubbles or anything. Get the most solid connection possible. Okay, and then just kind of smash that around, get the last little bits squared away. Now of course this is going to be rather thin. It's not a very thick piece of amalgam, so I might have to back it with something. How about one of these brass tags? That ought to reinforce it. Okay, let's try to make it as level as possible, and we'll just stick this on there. Stick, 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 stick. And that should form a pretty good bond. I'll just clean up all the little bits of stray mercury amalgam, and then just let it cure for a couple of days, and we'll see how all this works out. So it's been about 24 hours. You can see the objects are still here right where I left them. And one thing that is really interesting is this beaker with the mercury that I squeezed out of the copper. I put some water on top of the mercury to keep it from evaporating, and it's changed color in the 24 hours. So if I bring it up close here, you can see it's gained a gold tint to the surface of the mercury. I just thought that was interesting. So now we have the two pieces of copper that I've joined together with the amalgam, kind of like a very low temperature solder. And let's start, bend the copper and see if the mercury, well, strength test failed. Should have done an electrically conductivity test first. I can still do it. Well, it probably wouldn't have made too much difference had I remembered to check for conductivity before breaking it, because these pieces of copper were pretty much touching anyway. So let's turn up the voltage here. So we got a nice little test light. So let's connect that there. There we go. Copper conducts, of course. And when I touch it so that the electricity has to go through the amalgam, it also works. So it is electrically conductive. So it could be used as a solder, but not for any joints that have to flex. So here's a close-up of the broken amalgam on the copper. So you can see the mercury copper alloy has loads of little voids and cavities in it. It might be best to mix this up in a vacuum chamber or something to avoid that. Okay, so I've got this pipe hooked up to my CO2 cylinder so we can measure the pressure that's being produced. I'm only going to take it up to a couple of atmospheres. This is more or less just a leak test. So, alright, 2 pounds per square inch. And it's leaking like a sieve. Look at that. Didn't even put any pressure behind it. the mercury amalgam is porous, so it can't be used to patch a hole. Well, good to know. Let's increase the pressure just a little bit here. Alright, there's 10 pounds per square inch, so let's bring it up to a full atmosphere. So that's 1 atmosphere of pressure inside. And yeah, it's just going to sit there and leak. Well, how about that? Assuming contaminating it with mercury isn't a problem, maybe I could use this as a kind of a bubble stone. So now let's look at our little coin thing. You can see we did get some mercury on the back side of it, and it has discolored the brass. Let's prise this off of the wax. There we go. Well, it's backwards. Oh, that actually makes sense, because this is now our stamp. Okay. So it's time to try out the stamp. Well, let's do it with some softer metal. Got a chunk of lead here. Let's see if we can read the result. Just kind of squarely hit it. Oh, that sounded pretty good. It didn't break the amalgam. And look at that. Pinyon pine. It's not perfect, but that's pretty decent. Better than I thought. Probably should have done Cody'sLab, huh? Well, let's try a piece of brass. Let's line up a circle there and strike. Well, yeah, that broke the amalgam. It flat out flattened the letters too. So no, it cannot be used to strike harder materials like brass. Can do lead though. So the little chip that oh, well, it didn't stick very well because I just saw it move. And it come right off. It's interesting that it actually broke away from the mercury amalgam from the actual MOSFET switch. It seemed to actually have stuck better to the piece of aluminum. And speaking of the aluminum, you can see there is some damage to it. It has oxidized a bit. That probably is because when I smashed the little thing on there, some mercury was expelled, and that has reacted with the aluminum. So I had a closer look at this MOSFET switch, and what I originally thought was tinned copper was actually a metal covered in what looks like anti-seize. I'm sure it's some sort of thermal compound, but that wasn't making a good contact. Like, this has got oil and stuff in it. No wonder the mercury didn't stick to it. So I might scrub this off and try again. Here's the aluminum piece about an hour after I've removed the MOSFET switch from it. And if I can get this angled right, you might be able to see that there's like some hairs growing up. And the aluminum is decomposing. So yeah. Definitely can't use this with aluminum. So here's that switch after I've cleaned the thermal paste off and I've scratched it up with sandpaper. As you can see, it is copper with a tin coating. So I wasn't all wrong. It's very similar to what these leads are made out of. Now let's see if we can get the mercury to stick to it now. I have made another heat sink, so let's stick the MOSFET switch to this. See if this works better. I'm going to use this leftover bit of mercury here, so just add more copper to it, make a bit more of the amalgam. So let's put the amalgam on, same as we did before. Except this time, hopefully it doesn't destroy our medium and we get it to stick. Try to spread it out a little bit more this time too. Yeah, I think that's a much better bond this time. Okay, it's been another 24 hours. Looks like the amalgam has set up. Let's see if the chip stays on. Let's see if we can pry it off. Okay, I think I could still pry it off, especially if I like bent the copper, but it seems to be on there pretty good. So maybe I didn't need the bolt. That's kind of what I was testing. So here's the circuit that I've wired this into. You can see I've just glued this heat sink onto a little solar panel here, and zoom out a bit, you can see I've got it hooked up to a motor. When I shine my flashlight on the solar cell, the motor comes on. Made a little light sensor out of it. Don't see anything wrong with that. So there you have it. Of all the tests that I've done over the last couple of days, looks like the only one that was really successful was using it as a heatsink compound. Although I'm pretty sure the commercially available stuff and a bolt would be just as good, if not better. I think in the future I will play around with a little bit different mixture. You know, instead of just copper and mercury, maybe try a silver, tin, zinc, mercury amalgam, the same as used in teeth, because that's presumably a lot stronger, and maybe some other alloys. So until then, hope you enjoyed. I'll see you next time.